Hey, so now let's talk about how to use serial communication in LabView. When you install LabView, there is a software that is also installed called NIMax. If I open this software, this basically shows all the hardware that are installed that are actually connected to your computer and the drivers of them that are installed. So for example, if you purchase one of those box, the serial communication box that I showed you, there's a driver that comes with it, and then you have to install that driver. Once the driver is installed in your computer and the instrument, the box itself is connected to the computer and your instrument is connected to the box, so you have all the connections. Once you open this software, there's like a device and interfaces. If you expand it down, you'll see everything that is connected to the LabVIEW and to your computer. And here I have the NI USB 232/4, and I have four ports that are connected, three for my pumps and one for my weighing scale. So COM5 is actually COM port, and that 5 is number 5. What the COM port does is that there is an actual number that is assigned so that you will know where your instrument is connected. And so here I have 4 COM ports, and I know, for example, COM port number 5 is my first pump, and so on. And so start connecting your instruments one by one, and then you will figure out which one is which. And basically this is just assigned, and then you can make a label on your instrument and say that this is COM port number 5. So you would know. This is something that you will know. Okay, now that you know what is COM port and you know the baud rate, data bit, parity, stop bit, and flow control, you know all these things from your instrument, you can go ahead and build a program. That in this program I'm actually going to build a program that my pump is going to run with serial communication. I just want to let you know that I'm working on my laptop right now, and I don't have a serial communication device actually connected to it. So what I'm going to do is that I'm just going to build the program for you, so we are not going to run it. But I will assure you that this will run. There's no problem with that because it's actually running in the lab. But I cannot run it actually because and show it to you because once my program is running and I cannot close it and test it for the program that I built right now. And 2, I don't have a webcam to, like 2 webcams to really show you, like, here is the program running, here's how it looks, and all these things. But this program that I'm going to build right now is actually a program that is going to initialize the pump. So it's going to make a connection, basically a remote connection between a pump and the computer. And second, the pump is going to run based on a proper RPM that I assigned to it. And then the third, the pump is going to stop. So this is what I'm going to build today, actually, right now. So on the front panel, we need a push button which tells us if the pump is on or off. So if you want to turn on the pump and then run it with whatever flow rate that you want, or if you want to turn off the pump. And we also need like a toggle switch to say the direction of the pump, because I have my pump can run forward and backward, so I can define the direction of my pump. And then I can have a dial, and I can change it to become an indicator, because I basically want to show what is the pump flow rate. And I also need a control that I define my pump flow rate on it. So, and then my dial is also pump flow rate. So basically I'll type whatever flow rate that I want, and then the dial is going to show me what is the actual flow rate. Yeah, you can just organize this, and I'm not gonna take any time organizing this thing right now. Okay, so these are all the necessary things that you need to have to program, but the actual programming is actually the serial communication part. So the very first thing that we need to do is to initialize the pump. So I'm just like thinking, okay, the best approach is that you go to the instrument IO, and then you go to serial, and then you configure your port. Choose this and put in the block diagram. So basically this is gonna ask first which COM port number, which is this purplish thing here. So if I right click and say create a control, then I will have a control here that I can just define my COM port here, because as I said, I don't have any ports connected to my laptop. You don't see this, but if there was, like, let me see if I can show it to you here. In my actual program that is running, you can see I can define the COM port here, and it's running. I cannot change it, but you can define the COM port if there's actually something connected to your laptop. And because I don't have anything connected, this doesn't drag down to show me different COM ports that I have. But if you have an RS-232 connected an RS-232 cable that connects your instrument to your computer, you will have a list of COM ports that are in here. And as of now, I don't have any. And then the next is going to ask for baud rate, the data bit, the parity, all these things that I explained to you. You can just maybe easily just create a control of them, and then in the control you can type in whatever baud rate that your system has, or I would rather have a cluster of that. So do you remember cluster? So I'm gonna make a cluster. I'm actually gonna come here and go to cluster and choose unbundle by name, and then I'm gonna create a constant for this, and I will start adding the baud rate information and all these things, all the information in here as an enum constant, which is in numeric, and then enum constant, and I'm gonna define this enum constant as the baud rate, and I'm gonna edit this by adding the baud rates that I know. There's a ton of baud rates that you can choose, but right now I'm just gonna type two of the most famous one, which is this 4,800 baud per second or 9,600 baud per second. And then you can have it inside the constant, and then you will have this unbundled by name, but you need to have other unbundled by name, which are the parity, for example, or the number of bits, and all these things. So number of bit, and it can be like, I don't know, 4, 7, 8. Just define whatever number of bits that you have, and you can drag this down, put this inside, and then if I drag this down, this is the number of bits. And just continue having this for the others. I'm gonna add it for the parity right now, and the parity can be like non-parity, odd parity, even parity. There are also some other things that your instrument might have called a mark or space. You can keep adding based on the need of your instrument. So my instrument, I guess it's an odd parity. I will show it to you. So I guess, yeah. So this is the the baud rate, the data bit, the parity, the stop bit, and the flow control. So let's add the stop bit and the flow control to it too. So edit item and stop bit. I can have 1 or 2 depending how many bits as a stop bit I have. And then I also need a flow control. Edit items, and we'll call this flow control, and it can be no flow control, or it can be, and I forgot that. Let me check. Let me check what it was. Okay, it can be a no flow control, an RTS TDS, or a DTR DSR, or an X on X off. So there are different kind of flow control, again depending on your instrument. So I will say that I can have an X on or X off type of flow control, and this is type of like the software handshaking, and or the RTS DTS, I guess. RTS DTS. RTS, DTS, and just so on. Just keep adding whatever method you have. I think, yeah, RTS, DTS, and DTR, DSR are also among one of them. So you can just keep adding depending like on your instrument, and then you will choose based on your instrument. And yeah, so all I have to do is to drag this, and then the number of bits should be changed to parity. Oh, where's my parity? Maybe I forgot to name it. Yeah. So you go to edit items. It's important that you name the appearance of it, so that it will know here. Okay. So okay, I have baud rate, I have number of bits, I have the parity, I have the stop bit, and I have the flow control. So now I can start connecting this to the baud rate, the data bit, the parity, the stop bit, and the flow control. So this, if I go to help and waiting for the help to open. So this initialize the serial port specified by RESA resource name to the specified settings. So basically, what you're doing is that you are telling the LabView that my COM port number, whatever, like 3 for example, has this information. So these are my information, like this is how you should either receive or send signals. So this is what the configure VESA serial work. And then after that, you need to, for example, for my pump, I have to write to a pump, or I have to tell the pump what to do. The very first thing that I have to tell the pump is to initialize, to make a connection, a remote connection. So let me open the manual page of my pump. Okay, so here in the manual page, it's saying that R enable remote operation, and S requests motor direction and RPM, and for example, H halt the pump. And I know that inquire is ENQ, or it basically activates the RTS line. And I also know from my manual that the format should be something like that. I have to start the text or the STX, which is in here. STX start of text is the 0.2 code, so I know that. And then I also know from the format that I need to have a PO1 that basically define my pump, and then all the other commands that are needed. So here I have to write these commands to my serial command, to my instrument. So again, I go to instrument IO to the serial, and this time you'll choose, instead of configure port, you choose the write now. So you have to write to your what all the configure properties. You have to wire it to the write function, and then in the write function, if I right click and go to help, it basically, the purple asks for the visa resource name, which is again the COM port number, and then the write buffer is a pinkish thing. A write buffer contains the data to be written to the device, and it is pink. That means that I have to define a string. So I have a string command sent to my serial communication device, and that's how my serial communication device operates. And the manual is going to give me, the instrument manual is going to give me the command. So here I know the very first thing I have to do is to initialize my instrument. And by initializing, I have to do the enq or inquire. And again, here in the manual, it is telling me that the inquire is 05. So, and then I will have a backslash here, which is the start, and then 05. And that basically is gonna somehow inquire, like it's gonna inquire data. And then because I need to have some buffer inside my sender receiver kind of thing, so I need to have some wait time, so the buffer has enough time to empty, so I don't have a lot of data like getting inside and then overflow. I will go to the flat sequence, and if you remember from previous video, flat sequence basically means do this set of commands first and then go next and then go next. So I will add a flat sequence here, and inside a flat sequence I'm gonna add a time, a wait, and I'm going to tell my instrument to wait 100 milliseconds before doing the next step. But this is going to give enough time for the buffer to empty and send the data. So I'm going to connect my COM port number 1, and I also have some error out. These are the error clusters, if you remember. So I'm gonna wire all the error clusters to, what is happening here? Okay, now I also have to wire the error cluster between these two functions. Okay, now it's gonna inquire and then wait 100 seconds, and then next thing I want to initialize. And the initialize is basically another write function, and I have to type the proper command for it. So first thing first, you connect all these wires, the error wire and the visa resource wire, and then I have to make a command, a new command, and that command is a string. That's what we see it's here. And again, based on the manual, the command is 02, which basically means start of the text, and then I'm telling it name my instrument PO1, and then R means make the remote connection happening. So this is the commands that I have based on my manual. And then after that, when you are done with this set of commands, you come to the instrument, serial, and then you choose close, and then you have to close your this set of commands. But again, before you do that, you need another one of these flat sequence. So you give another 100 millisecond as a wait time for the buffer to empty. So you add another one of these here, and after that you will have you will be done. And then you can create also an indicator if you have any error, so that it will show you what the error is. So this part basically initialize my pump. So when I run this program, my pump at first it shows the screen on it shows like the direction, flow rate, and all these things that a user see on an LCD. But once I run this program, instead of the LCD being in a local mode that a user can manually change the RPM and all these things, the LCD space the window actually the LCD will change, so then it will just write a big P01 on it. So then I cannot see all the things that I can change to operate the pump manually, because now my pump is operating remotely. And this is exactly what this R function here means. So if I open the manual again, you can see here that R means enable remote operation. So once I enable the remote operation by this command, now the LCD on my pump changes from showing the RPM, the direction and time and all these things to a big P01, which is what I defined. And this is all based on my the manual, my instruments manual. From from instrument to instrument, it is different, this command. But the only thing that is different is the command, so the text file. All the other things are the same. You have to initialize your instrument, you have to write and then write whatever command that you have. You have to give some time for it so the buffer gets empty, and then you'll close it. And you just all you have to do is to have contact your the company that you purchase your instrument from, and they will give you the information regarding how to type these commands. So that was the first part, which is initializing the instrument. And I'm gonna make this bigger actually. So whenever I open this pump, I have to first initialize it, then go to the next step. And I don't want the initialization to happen over and over and over and over again. I want it to initialize once, so now my pump is in a remote connection mode, and then I will go and say, okay, now I'll turn my pump speed to this much, stop my pump, turn it on back again, and change the direction of my pump and all these things. But the very first thing that is needed for my pump is to make a remote connection happen. This pump and this specific instrument need this initialization or to make a connection, a remote connection. Some other instrument, they might not need it. So again, depending on your instrument. Because this is a very first step that has to happen, and then after that some other step will happen, and because this step only happened once, not over and over again, I have to put this entire program in a flat sequence. And then so if you remember, this thing first happened and then next and next, and then I can add a frame after, and I can change this flat sequence instead of like showing like frames of after frame after frame. I can make it a stack of frame so that my program doesn't get big and it's just a stack of orders. So replace it with a stack sequence. Now for 0 I have the initialization, and for the 1 are the other orders that I'm gonna write right now. But these are all very important. I need to know the baud rate, number of bits, parity, stop bit, and flow control of my instrument. And I want to show you like where you can again find it in your instrument manual. I think I have showed you this, but let's do it again. So the serial data that I have, it has the odd parity, 1 stop bit, 4,800 bit per second, and I don't have any flow control. So I can come here and say, okay, I have 7 here, I have odd, and I have 1 stop bit, and then no flow control. So then you can define the properties of your instrument in using the configure function, and then the structures that you define here, the cluster actually that you define here. So next thing, I'm gonna actually copy this part. I'm gonna actually copy this part because it's the same instrument, right? And I'm gonna go to this here, and I'm gonna paste this here. But I'm having a pump on and off, and if my pump is on, I will turn on the pump is gonna run. with whatever RPM that I defined. But if this switch is off, then the pump has to stop. So that's why I will have a case structure here, a very big case structure I need, and I'm gonna connect this to a case selector. So now if my pump is on, this is true, and now I'm in a true page, and I have to define the command that basically runs my pump. So let's get started. Again, you need to go to the instrument IO serial and write, and you have to connect, all these things, and define define the command that is needed to turn on your instrument, which is your pump. So I will bring all these things inside. If you remember, the write function needs a string command. So I have to somehow make something that the direction of the pump flow rate, and all these things are transferred to a string, that I can send that string with some other commands that is in my manual to the write function. So this is done by a function in the string tab, which is called concatenate strings. So what concatenate string does is that if I go to the help, concatenates input strings and 1D arrays of strings into a single output string. So I can add too many different strings command, and it's gonna be added into one big string. I remember in some previous video I've talked about it, and this is what it does. So because we need a one single command that we are gonna send it to the instrument with the write function. So the very first thing is that I have to tell the instrument if the direction of the pump is forward or backward, meaning if the pump is running forward or if the pump is running backward. So I'm saying if. So because I'm saying if, I need a case structure. So what it says is that if the direction of the pump is, for example, to the left or to the right, or it is true, this means that I have a string constant, for example, a -1. And if that is false, then my string constant is gonna be a positive sign. Because in my instrument manual, it is saying that add a negative or a positive for for example, a forward pump direction or a backward pump direction. You can always test this. If it is negative or positive, once you've built your program, run your pump and see if it's running forward or backward, and then you can change a negative and positive in your program. So this is easily fixed. And so this is how I have basically defined the direction for my the positive or the negative direction for my pump. And that goes first in here because at first I need to know it's positive or if it is negative. The second thing is to change the flow rate into some string number, because the flow rate is the floating point number, it's orange, and I need to have it in a string. So again, you come here to the string, and we have a number string conversion. You choose a number to fractional string function. And again, if you go to help, this is super easy. It's going to show you, like, if you type your number, defining your width or your precision, you will have like different way to interpret your number and get your number as a string. So you can just read this and decide based on how big your number is, how large of a width or a precision you need. So here I'm just gonna create a constant for each one of them, and then I'm gonna define a width of 5 and a precision of 2, just because this is good for me. And then what we'll need is that we will connect the pump flow rate control to it, and then I will have a string. And now, so whatever number I type, for example, 25 RPM, that 25 RPM is going to change from being a floating point number to a string. And this is my indicator, so I'm going to connect it to here, which is basically my dial, which is going to show it also for me what is the flow rate. So this is going to be the flow rate, positive or negative of, for example, a positive 25 RPM. But again, based on the manual of my instrument, for me to set an RPM or speed, I need to type an S. But an S should be followed by some other command, which is always a constant command which comes with my instrument. Like we did it here. Like here we had backslash 02 PO1 and then an R. So I have to type backslash 02 PO1 S and then my flow rate. Okay, here. So I will need to have another concatenated string because I have to add that also, the other command. And the other command is coming first, so I will say create a constant backslash 02 P01 S, and that means set the pump flow rate and basically RPM to this number, which is the second, and then make sure that this is on remote order, so the pump is running remotely. So this is basically all the commands that are needed for me to run the pump, and I'm gonna send these commands here, and then I'm again gonna add a wait function here because it is needed for me to empty the buffer. Make sure that you are always having some kind of wait. Otherwise, after a while, you will get error in your system. And then after that, you're done and you can just add a close. You need to close your communication. Because I will basically send the signal, the order, which is run the pump at this speed, and I'm just going to send it one time. I'm not going to send it over and over again. And then whenever I want to change something, I will just run it one more time again. So you basically open and then write and then close. And you will have an indicator of if there is any error. So let's copy and paste the entire thing, which is basically whatever I had if the pump is on. And now if the pump is off, this is gonna go to false. And it's actually easier because if that happens, I don't need to have all these things. The only order that I have to send to the pump is to stop the pump. So I'm going to delete everything here, and the only order is that I don't need to say positive, negative, RPM, whatever. If I want to stop the pump, stop the pump. So I'm just going to type the order that is needed to stop the pump, which is backslash 02 P1 and 01 and then an H. This is how to stop the pump, and then I also have to make sure that this is remotely being controlled. Like I did it in the first step, I made sure that it's remotely being controlled, and in the second step when it was running, and I made sure that it's remotely controlled, and also in the false case, which when the pump is off, I make sure that it's remotely controlled. So this is a program, like a serial communication program, that actually shows how to run a pump remotely. It's super easy. All you need to do is to define the properties of your instrument, which comes with the manual. Then you need to just give that property to the LabView with the Visa configure function, and then you need to write to it. If you need to write to your instrument, if you want to read from your instrument, this is going to be a read. For example, I have a measuring balance and I want to measure the weight on my balance. So this is going to be a read rather than a write. But for a pump, I'm going to run a pump, so I'm going to write to a pump. So this is like a difference between a read or a write. If you want to send a command, or if you want to read a command, or if you want to send and read at the same time. So you can choose a read or a write function. And then you can also close your serial communication port to have a clean program. And the only thing that is a little bit tricky is to know the command. And I agree this is not easy and simple. I really recommend reading the manual of your instrument, and if you feel like you cannot understand it, you can always call them and they are helpful and they can give you the commands. You can also Google them, like for example for the measuring balance that I have in the lab, I couldn't find the manual for it and the commands, and it was confusing for me, so I just Googled and I found a really nice person who already made the command and they were all ready. So there are too many different ways that you can come up with the command. I hope this video was useful for you, and these two videos that the previous video and this video, they were for the serial communication device. In the next video, we're going to talk about data acquisition, that is basically reading the voltage and current signals. And trust me, that one is easier than this one. I like to I like to talk about the hardest one first. Okay, have fun. See you later.